Good morning and welcome back. We are here and ready to do lesson 3 today, and we're going to start with the application problem, and that's on page 135 in your blue book. So if you want to turn there, I'm going to go ahead and read this, and you be thinking about how you would solve it. You can even pause the video and try to solve it and then come back and check your work. Hudson is choosing a seat in art class. He scans the room and sees a 4-person table with 1 bucket of art supplies, a 6-person table with 2 buckets of art supplies, and a 5-person table with 2 buckets of supplies. Which table should Hudson choose if he wants the largest share of art supplies? Support your answer with pictures. Okay, so if you just start drawing pictures, that's probably the best strategy for this one. If we draw a table, the first table was a 4-person table. So 4 kids sitting at this table, and there's 1 bucket of art supplies at that table, okay? And you could even write yourself a fraction. 1 bucket of art supplies for 4 people, okay? Well, the next table is a 6-person table. So we'll draw a little bit bigger table. There's 6 kids at this table, and there's 2 buckets of art supplies. Okay, so 2 buckets of supplies divided by 6 kids. So notice how I said that, divided by, but I wrote a fraction. 1 bucket of art supplies divided by 4 kids, 2 buckets of art supplies divided by 6 kids. Well, just out of these two, what's a better ratio? Or what, which fraction is better if he wants more supplies? Well, you have 1/4 versus 2/6. If you think about that simplified as a third, well, 1/3 is bigger than 1/4. So this is the better deal right now. Or think about it as 1 bucket of art supplies for 4 kids sharing. Or think about this, since there's 2 buckets, that's half the table. 1 bucket of art supplies for 3 kids. Well, 3 kids sharing a bucket is a better deal than 4 kids sharing a bucket. So this is better than this one. Okay, so I'm gonna cross this off. That's not the best table. Okay, so now let's think about this versus the last table. The last table has 5 kids sitting at it. So 1, 2, 3, 4, 5 kids sitting at this table with 2 buckets of supplies. Okay, so 2 buckets divided by 5 students. Okay, so now you're thinking about this. What's a better deal here? Well, if you think about, well, if you have 2 buckets shared among 6 kids or 2 buckets shared just among 5 kids, well, that's a better deal. Only 5 kids are sharing these 2 buckets where 6 kids are sharing 2. So this is the best table for him to sit at. So that was the application problem. So let's go ahead and look at the problem set today. It is really just solidifying what we talked about yesterday, how fractions are really just division problems. Okay, so turn in the next page in your blue book. So you'll be on page 137. 137 is our problem set for today. And let's look, notice that it's a big chart. So take a look at this chart. We're just supposed to fill it in. Okay, so we have a division expression. Okay, then we have unit form, an improper fraction, a mixed number, and then a standard algorithm where you show the long division. It says write your answer in whole numbers and fractional units, and then check. Okay, now let's just look at this first one. This says 5 divided by 4. Okay, remember yesterday we said we could write 5 divided by 4 as 5/4. That means 5 divided by 4. Okay, so this we kind of learned yesterday. We also did the unit form yesterday. And this probably might be the most confusing part, the second column to do. But let's think about this a second. Remember yesterday we had 5 whole crackers and we divided them each into 4 units or fourths. So how many total fourths would there be? What's 5 times 4? 20. 20 fourths. So notice that's the first part of the problem. 5 whole is the same as 20 fourths. Okay? Now you're still dividing by 4. Okay? So probably this part is the hardest part for you to get. Okay? But remember, just think through that. 5 crackers divided into fourths. 5 times 4 is 20 fourths is your unit form for 5 whole. And if you do 20 fourths divided by 4, it would be 5 fourths. Okay? And this unit form answer should match your improper fraction. Okay, now 5 fourths written as a mixed number. Okay, you can do the work here and then put your answer here if you want. Remember, when you take an improper fraction and make it a mixed number, you're really dividing. You say, how many times does 4 go into 5? Notice that's what we write over here. How many? It's like you take this and tip it over sideways. Okay? How many times does 4 go into 5? Okay? Remember, the top number, your numerator, is your dividend. It's the one that goes in the den. So 4 goes into 5 one time. 1 times 4 is 4. And then how many are left? 1 is left, so it's 1/4. You always put it over the divisor. Remember, we had fourths, so that should be the denominator. Okay, 1 and 1/4, and that's what your mixed number will be. Okay, now the check, Miss Ballard said we don't have to do, so you don't have to do that. The check, remember though, is you always multiply this times this. So how many? 4 times 1 and 1/4, you should come back to 5 whole. Okay, but we don't have to do that today, so that'll save you a little bit of work. Okay, so let's go to the next one. 3 divided by 2. Okay, I like to jump over here and do this part first because it's easier. 3 divided by 2 is 3 halves. Okay, if I had 3 whole crackers and I divided them each in half, I would have 6 little halves. So that's what I would put here. 6 halves divided by 2. 6 divided by 2 is 3 halves. And notice that matches what I put right here, 3 halves. Okay, now notice they already gave me the mixed number, so I'm going to show how I got that. 2 divides into 3. Okay, 2 goes into 3 one time. 1 times 2 is 2. I have 1 left over, so I put that 1 up here in my numerator. And remember, my denominator was halves, 1 and 1/2, and that matches here. Okay, you might pause and try the next one by yourself if you're feeling brave. Okay, well, let's take a look at it. Let's see what they give us here. And I would notice this says 6 fourths. So that should, remember, that should match my improper fraction. So if I'm having this right here, 6 fourths, and notice that's 4 dividing into 6, that's what they show me here. So I'm like, okay, well, that would make sense. 6 divided by 4. That would mean 6 times 4, I would have 24 fourths. Divided by 4 is 6 fourths. So this all matches. Okay, now 4 goes into 6 one time. 1 times 4 is 4. I have 2 left over. And remember, my denominator was fourths. 1 and 2 fourths is my mixed number. And remember, 2 fourths, I could have written a half, 1 1/2. You can write it either way. Okay, let's look at this last one. Notice they give us the 5 divided by 2, and they give us the 5 halves. So we have to do the unit form on this one. Okay, 5 whole crackers. If you divide them each in half, that means you have 10 little halves. So I'll say 10 halves divided by 2 would be 5 halves, which matches my improper fraction. Okay, so let's check to see that this is right. 2 divides into 5 2 times, because 2 times 2 is 4, and I have 1 left. 2 and 1/2. Check. All right, so hopefully you followed that okay. So let's take a look at the next page. All right. This says a principal evenly distributes 6 reams of copy paper. So think about that as a package, 6 packages of copy paper to 8 5th grade teachers. How many reams of paper does each 5th grade teacher receive? Explain how you know using pictures, words, or numbers. Okay, so a very important thing to remember here when you're writing a division sentence is think to yourself, what in this problem is being divided? Okay, is it the teachers or is it the paper? Well, it's the paper. Okay, the 6 reams of paper is being divided among 8 teachers. Okay, that's really important so you don't get your numbers in the wrong spot. Okay, the 6 reams of paper are being divided by 8 teachers. Okay, so 6 divided by 8 we can write as a fraction like that, right? And we can simplify that fraction. If you divide both these numbers by 2, you get 3/4. And guess what? That's your answer. Okay, each teacher gets 3/4 of a ream of paper. They don't get a whole package. Because think about it, if you have 8 teachers, for them to even get one whole package, you'd have to have 8 reams of paper, but there's only 6. So they only get a part of a package of paper. So each teacher gets 3/4 of a ream, but each teacher gets 3/4 of a ream of paper. Okay, now look at this next question. It says if there were twice as many reams of paper, wait a minute, twice as many, that means times 2. There were 6 reams of paper, so that means there are 12 reams of paper right now. I'm going to jot that down. 12 reams of paper. And half as many teachers. Well, there were 8 teachers up here, so half as many would be 4. Okay, so 4 teachers now. Okay, twice as many teachers, so that would be 2 times, or twice as many reams, sorry, 2 times 6 is 12. Okay, half as many teachers, so a half of 8 teachers would be 4 teachers. Okay. How would the amount each teacher receive, how would that change? Okay. Explain how you know using pictures, words, or numbers. Okay, well, if we have 12 reams of paper divided among 4 teachers, I could write that as 12 divided by 4, like that. But we know 12 divided by 4 is 3. Ooh, so those teachers get a lot more paper, don't they? They get 3 whole reams, where up here they only got a part of a ream. Okay, so in this case, each teacher got 3 reams of paper. Each teacher gets 3 reams of paper. Okay, so hopefully that makes sense to you. Let's look at this last question before we're done. A caterer has prepared 16 trays of hot food for an event. The trays are placed in warming boxes for delivery. Each box can hold 5 trays of food. How many warming boxes are necessary for delivery if the caterer wants to use as few boxes as possible? Explain how you know. Okay, so we have these 16 trays of food, okay, and they are going to be put in these boxes. And I can put 5 in each box. Okay, so you can even think tape diagrams in this problem if you want to, but you have the trays of food is what's being divided up. 16 trays is being divided into these boxes that hold 5 apiece, okay? So it's like you have, here's a tape, here's a box, and I put 5 trays of food in it, okay? Here's a box, I put 5 trays of food in it, like that. Okay, so 16 divided by 5, you could write as a fraction, like that, 16 divided by 5. Well, what is 16 divided by 5? 5 goes into 16 3 times. That's 15 with 1 left over. Okay, if you look at your tape, you have 5 trays, 5 trays, 5 trays in these 3 boxes. That's 5, 10, 15. The last box only has 1 tray of food in it. Okay? So if it asks how many warming boxes are necessary to deliver all the trays, that would be how many boxes? 4. You have to have 4 boxes to take all the trays. So we would say 4 boxes are needed. Now, if you look at the last question, it says if the caterer fills a box completely before filling the next box, what fraction of the last box will be empty? Well, this box only has 1 tray in it. It can hold 5, okay? So what fraction of the last box will be empty? Well, 1/5 of it is filled, so that means 4/5 of it is empty. So hopefully that makes sense to you. If you can even think about this last box as there's the 5 trays that could be in it. Only 1 tray is in it. So it's only 1/5 full. It's 4/5 empty. Okay, hopefully that makes sense to you. Go ahead and try the homework and we'll see how you do. See you soon.